Hello, everyone. Thank you for having me here at Rework AI Summit. My name is Harsha Aduri. I'm an applied scientist at Amazon. I work in the Seller Partner Services org, where I lead the issue understanding science group. Today, I'll briefly be covering our internet ecosystem and how it supports sellers on the Amazon Marketplace. So today, we'll talk about how we tackled the common pitfalls of every ML project or ML system, like cold start, label noise, and keeping up with customer and business use cases, and went on to build an agile and scalable issue understanding ecosystem that uses over 200 text and non-text features and close to 1,000 target issue types. And also, it continuously evolves and adapts on demand to customer needs. This is a brief overview of what we'll be talking about today. First, we'll establish the problem that we're trying to solve and the different considerations we took into account before we got started. And then we'll talk about how we evolved our ML models and what we learned along the way doing so. And the last thing, before we leave, we'll talk a little bit about what you're doing next, kind of a sneak peek. First, before we jump too deep into the problem space, I want to establish some context. How we in the selling partner support work. So one critical thing here is to understand the seller support journey. We have sellers on the Seller Central page, which is kind of the homepage for sellers, equivalent to Amazon.com or Amazon.ca for buyers. This is where they manage all of their inventory, sales, shipments, and the end-to-end life cycle of their accounts. Whenever they face an issue or need any form of help or support from Amazon, the first place that they reach out is called Help Hub. Help Hub is the central repository of all issues and help articles that Amazon provides. And this can be used to solve their issues. And if that doesn't help, they try to contact us through a Contact Us form on the Contact Us page. And these cases are then routed to support agents that we employ on scale. At each of these stages, we try to resolve the seller issue as best as we can, and then provide a resolution back to the seller. And we do all of this at Amazon scale. Amazon supports over 2 million active sellers, creating over 1.5 million contacts every single week, which are serviced by one of our 15,000 in-house support agents. The number of sellers has grown over the last couple of years, with 200,000 new sellers just into 2020 alone. Selling partners have reached out to us over 300 million times just this year. And this was just as of me making this presentation. It must have grown since then. I guess you guys are seeing where we're heading into a problem here, right? The problem we have is multifold. First, the scale and growth of our selling partners poses an inherent scalability risk for our systems. It is not reasonable to hire and train support agents to meet Amazon level of bar fast enough and efficiently enough. And second, on the other hand, we want to provide the absolute best seller experience and satisfaction to our selling partners, which means providing more value-added experiences and in a much faster way. And last, eliminating the sources of this pain for sellers. Understand where the sellers have the most friction and combat these issues at the source. So these are the different areas that we want to tackle as part of the solution that we're trying to build. But what are the different considerations? We have established that we need a solution, but we need some things that we need to consider before building it. That's where the 3 pillars of success comes into play. Every ML project has 3 main pillars that lead to its success: feasibility, purpose, and data. Now let's look at how each of these apply to the support use cases. First is feasibility. Whether it is technically feasible to implement a solution, whether there is the right hardware and software support to execute the project, whether the ML research has advanced enough or can be advanced enough to a stage where we can put this ML solution into production. For the problems in the seller support, we have discussed earlier, we chose the intent classification or the issue understanding problem solution to help us understand and act on the seller issues and queries. And it is feasible to implement such a solution with existing models. The second thing is purpose. We need to have a clear and defined purpose. What I mean here is there a customer for this solution? Are we solving a particular customer need with this project? Are we delivering a better customer experience with this? And also, is there a return on investment? Are we building this solution just for the sake of it because it's a cool tech? Or do we actually reap end customer benefits out of this? To that extent, let us look at how the solution that we are proposing helps seller support. First, we have seen the seller support journey before. To understand how we optimize seller support process, let's look at how this solution helps in every single stage. When support agents look at these cases, we can surface tools and SOPs and other things that will help associates solve and understand the seller issue faster. And we can go one further level up the chain. And if we provide these services and solutions even faster and interact with them to disambiguate and also provide better support. We could also use these tools and solutions before routing to an agent. If we are able to understand that this might not need an agent at all, these can be automated, or even to route them to the associate with the right skill set. And once all of this is solved, we have an end stage at post-resolution where we want to look at all the issues, deep dive into what caused them, where the main friction and issues that sellers are facing, and then also to optimize our workforce. All of these individually adds value to our end customers. The third one, and the more equally critical one, is data. Do we have the right kind of data and the right amount of data? Well, let's start with the basic question. How much data do we need? The age-old question with no right answer. Anyone you ask will tell you, more data is more better. But we tried to empirically arrive at the right answer to this question and tested on a small subset of classes and increasing the amount of data at each class to test the performance. What we noticed was we noticed an 80% precision with just 2,000 cases or data points per class, and diminishing returns beyond 10,000 cases per class. Does that mean we just collect 10,000 data per class and we're done with it? Probably not. By labeling 10,000 cases per class, the entire label set would have taken us over 77 years to manually collect these data points. So we settled on a more reasonable 10,000 cases per median density category. Another thing to keep in mind is that labeling this data set once is not enough. You have to keep up with the customer demand. So you have to refresh the training data and as often as possible to stay on top of both customer needs and the business needs. So how do we get this data? Since we are trying to automate seller issue classification, which support agents do manually today, which means at the end of every case resolution, the support agents have to say, I think the issue is of X type. So at the end of every case, we do this manually today. So we introduced a human-in-the-loop system where we can tag initial cases for training, but also at a later point, verify the labels assigned by the ML models. This approach allows us to have a mechanism and infrastructure for future retraining as well. Another important thing to make note of here is, I know we talked a bunch about the training data part, but another critical thing is focusing on the labels themselves. Carefully curating the target labels can save a lot of headache in the long run. We can avoid pitfalls in missing labels in training data set, losing volume due to improper data curation, and also other pitfalls related to if you are considering only X amount of time of data and certain labels don't appear on it, you might not be predicting very well on them. The solution we employed is curating a business-defined taxonomy of all seller issues arranged hierarchically to capture different granularities in the issues. It looks something like this. So at the root node, at the root level or the first or the level 1, we have broad issue categories like issue A and issue B. These could be defined. These could be business areas. In the case of Amazon, it could be something like advertising or Prime or something else. And one level down, we can have issues related to specific subcategories in each of these business areas. And one level down for the granularities, and one level down for the more granularities. And you can keep going on until at the leaf node, you have the most granular issue a seller on Amazon Marketplace can face. And to keep up with business, establishing a process to update the taxonomy periodically to reflect new use cases and trends and expansions that your business is taking will help you evolve with customer needs. And establishing a process to store these mutations will help future retrainings smoother experience. And it also helps with better label collection, better trained data curation, and also eventually better models. Talking of models, we've established the three pillars. Now let us look at what we have built on top of these foundations and how our classification framework evolved over the years. The intent classification ecosystem had humble beginnings. Our first challenge at hand was to automate the tagging of support cases. That was the primary problem that we were trying to solve. And we did just that using our hierarchical ensemble of logistic regressors. Each LR was trained on a specific node in the taxonomy with a bag of words style vectorizer on seller text. What I mean by that is, we have seen this taxonomy before. For every node in this taxonomy, we have a single logistic regressor that would just classify the seller issue into one of the broad issue categories. So at the top level, we just classify it into which business unit it belongs to. And if it says issue A, then we pick the LR that is corresponding to issue A and then further classify down and further classify down until we reach the final solution. This approach is pretty primitive, but it worked well and helped us launch the project off the ground. And we were able to provide significant value add to the associates by auto-assigning these labels and showing them the right related tools. But then we also hit a problem. While that approach worked well for most of the time, any mistake the LR higher up in the tree meant that there is no way we could reach the right leaf node. In other words, there is no error propagation up the hierarchy to correct for these mistakes. We then moved to a hierarchical CNN architecture using word2vec and the best CNNs available at the time, and that aided in text classification. It looks something like this. So we have the base CNN framework that allowed us to branch out, and we built custom layers on top of it. This architecture allowed us to predict independently at each level of the taxonomy for each case. So in cases we have low confidence at lower levels or most granular levels, we could always fall back to a coarser level of the taxonomy and recommend tools that are related to that instead. This approach allowed us to learn from our training errors at each level and boosting our model performance across all categories. Then came more trickier issues. Distinguishing nuances in text, understanding statements in context, and also separating closely related classes was a big challenge for the CNN architecture. Now we enter into the age of transformers or attention-based models with pre-trained, fine-tune, and predict philosophy brought about by the BERT class of models that we are all familiar with. But instead of diving headfirst and then picking out the best model that is available on model zoos across the internet like Hugging Face, we wanted to set up a reusable infrastructure that would allow us to test several different architectures and approaches and iterate fast. We employed a two-stage pre-training process for domain and task adaptation. This allows the models to learn the vocabulary and the domain of seller support issues effectively and then understand them very well. We tested several different architectures, graded them on a multifaceted rubric to find the best model that fits each different use case that we have in seller support. This is roughly how the multi-stage pre-training and fine-tuning architecture works, where for each transformer model, or something like BERT, Albert, Distelbert, or whatever you name, right? We take the pre-trained public version and then further pre-train on the seller domain, and then continue pre-training on the task-specific data before finally fine-tuning on the labels for that particular task. And establishing this reusable components and framework allowed us to do rapid experimentations and find the right combination of models and hyperparameters for every single use case. In this case, each of the tasks can be intent classification, entity recognition, or any of the different use cases that use language models, right? The final fine-tuned transformer reduced the interlabel confusion and pushed our ML model performance much closer to human accuracy. Now, now that we have achieved such high level of performance, we wanted to dig a little bit deeper and understand specific areas where our model still lags behind. One area we struggle is when SPs provide little to no information regarding the issue that they are facing and are able, so we are not able to solve the issue for them. If a seller is facing an issue, language models are only as good as the text that is provided to them. If things like please help or call me are prime examples, right? This is especially prevalent in live channel contacts where sellers provide little information upfront and clarify the issue later when a support agent is engaged. But as we have seen in the seller support journey earlier, engaging with a support agent is the last step in the funnel. We have already late by the time an agent is engaged, and we have missed so many different opportunities to engage with the seller and help them along the way. So we try to look at how a support agent does this. We try to shadow several agents and try to understand how these people are able to accurately classify the issue types. And they do it in two main ways. One, disambiguate. Ask follow-up questions to clarify the actual issue and help them. Second one, context. They go looking into the seller account to understand the potential sources of the seller issue. For example, if the seller just says, please help, I don't know what's happening with my account, they could go and check the account health dashboard and see what are the different things that are happening there. Are there errors popping up? Are there specific things that are out of the ordinary, and use them to help them? So we collected and incorporated several text and non-text sources into our transformers and give them the best context they can and the same level of context that a human would have when solving a case. Come on. Yeah, sorry about that. We use something called multimodal adaptation gates to incorporate different modalities into the model. Different modalities are first run through an attention gating layer before finally making it to and added to the primary lexical input. This approach improved cases with little to no text and also live channel cases by over 35% and helping us bridge the gap to human accuracy even further. We are able to do all of this in different ways. There's also, more recently, we've been targeting other areas where we can improve our model. We have already checked that we're able to do pretty well on specific use cases that are related to live channels, short text inputs, or even other areas where we don't have information from the seller. What we want to do next is move completely away from the fact that seller has to provide us input. We'll talk about it a little later. But first, we've been talking about all the things that we have built. So what are the different things that we have learned along the way that helped us? First thing, the cold start problem. It's a big issue that everybody faces. And my manager used to say, good data triumphs great algorithms. Collecting the right training data that is of good quality is very critical. But imposing label collection as a mandatory task can result in inadvertent results or even circumventing tactics, and even in some cases, random label selection by the annotators. We need to incentivize the label collection instead of just mandating it. How do we do that? The two tenets that spearhead our approach to incentivizing labeling are: one, the result of labeling should be obviously beneficial to all labelers. What I mean by that is, the labeler should see that there's a very clear value add to the task that they're doing at hand, and that it will benefit them right now, not 2 years later when you're finally able to build an ML model that will help them. And two, not labeling should have no less friction, but not to the point of causing bad labels. Sorry for the double negative here, I'll explain. They should not feel that not labeling will get them to the end of the task faster, but also not in a way that labeling will get them to the right solution. So they need to be sure that if I label, I'll get to a solution faster. Our solution here was to map the tools that supports agents to the labels of the case. So selecting a right label for the case will show recommendations related to what are the different tools that can be used for these particular types of issues. What are the different workflows or diagnostic steps that can help with this issue resolution? And what are the different SOPs or anything else that is related to that particular issue type? Or maybe there is, if they are not the right associate to help with that, Selecting the right label will also help them route it to the best associate who can deal with that particular types of issues. And of course, they can look up all of these tools and SOPs themselves, but labeling the case will just get them there faster, which means that now the associates and the support agents are incentivized to select the right label instead of just skipping the step or selecting a random label to just end the case right there. This approach allowed us to mass collect labels for support cases from all support agents working on them, not just specific subject matter experts. While support agents are subject matter experts in this particular annotation job, they are also prone to biases of issue interpretation. Slight differences in understanding the issue, albeit valid, result in slightly different labels assigned to the case, which meant our SMEs only agreed about 60 to 70% of the time on mono-labeled cases. This agreement, however, jumped to 85% when considering the top two labels. The important takeaway here is to accept that human annotated labels can be noisy, and the labeling solution and building solutions around it is important. Iterative solutions with continuous feedback loop is key to success here. And there's several different machine learning techniques as well you can adopt, like adaptive learning and also label-aware learning that will help you reduce the label noise. Although this effectively establishes a ceiling for the performance of ML models, it's a trade-off that we need to encounter because our subject matter experts, our data is only as good as the SMEs. And the other one that I want to talk about is always look deeper into our data. Holistic metrics like accuracy, recall, precision, and everything else will give you a good overall picture of how your model is performing, but fail to capture the nuances hidden in data. Looking at specific errors, commonly misclassified or confused classes, or even certain patterns of cases that are being misclassified will help you understand and uncover a lot of issues that you might otherwise miss. It is important to understand that even if a human with all of the contextual data available to him is not able to accurately assign a label to your case, it is very likely that your model can't either. If something just says call me and there is no contextual data available and there's nothing significant happening, or it's just please help. If an annotator cannot assign a label accurately to it, it is very much possible that your model is going to fail there. Dealing with multiple languages was a big pain. Most tokenizers in NLP are language specific and require specific on separate pre-processing. We initially built one language per model for each of the major languages in our the sellers interact with us in. While it provided good performance on the cases that correctly came to each of these language-specific models, poor language detection hindered our progress. Sellers regularly use code switching or switching between two different languages within a single case, or insert things like entities such as URLs, product titles, descriptions, which could be in a different language than the case itself. Our solution was to adopt multilingual models that offer language-agnostic preprocessing and tokenization without the need for a language detector. Talking about entities, another way we dealt with these is masking entities within text. Our entity extraction models accurately identify and mask several different kinds of identifiers like titles, shipping IDs, tracking IDs, URLs, product hierarchy paths, something like fashion, men's pants, and so on. All of these are masked within our training data and also inference data. And this helps us in focusing on the actual seller issue without any distractions. And our entity extraction models are really good at it. Another thing that causes noise to our models is boilerplates and templates. It's the last thing that I want to talk about here because there's a lot more issues that I want to limit the number of things that we talk about. Inserting a boilerplate or template or other filler text provides no information related to the seller issue, but rather adds noise to confuse the models. We have built solutions to identify recurring boilerplate patterns and other templates like salutations, signatures, pre-formatted form text like you can set name, issue, enter your issue ID here, and things along those lines, and mask all of that information. This helps us focus better on the seller issues. So we talked a bunch about what we have done so far, what led us here. But I want to leave with a small snippet of what we have been working on and where we are headed next. So we've seen how the intent detection lifecycle helps the seller at every stage. But predominantly, all of these rely on the seller coming to us for support. Or in other words, we are providing reactive support. For the next chapter, we're trying to see if we can meet the seller where they're at. So one of the things that we want to solve is in context support instead of having them come to us for support. So we want to completely eliminate the need for seeking help. Sellers can sellers have several different contexts, and at every stage, they are providing us implicit information. Is there any stage at which we can recognize that, hey, I think the seller is facing an issue? Can we help them? Or even provide in context help? We are looking to see if we can be proactive instead of being reactive in our help and offer support to the sellers. I can't talk a lot about the details here, but expect to see some major changes to the support ecosystem soon. I think that brings us to the conclusion. Thank you.